All right, so when we last left off, we had a direct hashing mechanism here at Old Westbury, and our direct hashing mechanism used the 700 numbers to be the index into the array. Now this works in terms of having a quick lookup time, right? O of 1, we just jump straight to that index. It doesn't work in certain aspects. In one way, we're just wasting a bunch of memory, okay? And so how do we make it so we don't waste a bunch of memory? Some of you probably have already thought of a perfectly good solution, right? What if, well, this is really the first value, and this is really the last value, okay? And so what if we did something where we, can you see that? Or should I just be using, I could turn on the lights, but I'm not going to. If we just literally say, well, this one should be the 0th index, and this one should be the final index, n, right? And so, or the final index, right? And so this is our 0 index, right? And this should be our final index, right? Which would be that. And so dot, 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 all the way to 999, 999. And now instead of having a 1, 2, 3, comma, 1, 2, 3, comma, a 700 million size array. Is that right? 700 million? Seems like a lot, right? 100,000. I don't know why I'm having so much trouble with this. Yeah, a 700 million size array. We've now gone down to 100,000 size array. Pretty good, all right? Well, but then how do we make it so that we know that 700 million is, oh, I guess it's 701 million size array, right? We've gone down to 100,000 size array. But we have to now do a little math to say this is going to go to 0 and this is going to go to 999,999. All right? And the math we're going to do is we're going to take the key. So we take the key and we minus this number, right? 700. Okay, we minus that number, and that gives us our index. So we say our index, where we store the values, equals the key we have minus that number. Okay, and so if someone comes in with the key value of 700,000,000,000,000,000, the first Old Westbury student, the one who got it all started, all right, comes in and it's like, I want a time machine so I can go back. I will forget it. What we're gonna do is we're going to take that person's key and we're gonna minus this number, and that'll say, oh, 0, and then we go to the 0th index and we look up that student's record, right? And that student probably graduated in the major in dot matrix printing. Look it up, and then we can go on from there. And then the final student or whatever, right, we can minus that number, and everything else would be given an index in between. All right, this is already better than what we had. And this is called a hashing function. Okay, a hashing function takes in a key and returns an index. Okay, so your hashing function takes in a key and returns an index into the array. Okay, and that's always what a hashing function does. Takes in a key and returns an index. Okay, now and returns an index into the hash table. Let's just hash table. So a hashing function takes in a key and returns an index into the hash table. Okay, so pretty cool. All right, so this is what we call a minimum perfect hash. okay? And what a minimum perfect hash means is that every key will hash to a unique index. So every key hashes to a unique index. And the table is big enough to handle all those indexes, okay? So it's not like the table's too small. And table is big enough to handle all those indexes. Pretend I wrote that down there, okay? And the table is big enough to handle all those indexes. So we have a minimum perfect hash here because every key, these 700 numbers, hashes to a certain index, right? And the table is big enough to handle all the records. It's not like we just have a table of 10 things and then we have to figure out what to do with that. All right, so that's a minimum perfect hash. And that's the, that is kind of the best thing you get. It's minimum because there's no wasted space. And it's perfect because every key hashes to a unique index, okay? So minimum, no wasted space, unlike that previous example, right, where we did direct indexing. And perfect, because every key has its own index value, all right? And that's kind of the best you can do. If you have that, that's amazing. Now, for various reasons, as you might already be thinking of, that's not always possible. And we'll go into those the next video. But minimum perfect hashing, man, pretty cool.